Hey all, welcome to today's daily Leetcode challenge. Today I'll be solving question 70, climbing stairs. So this is an easy level question and the description goes as follows. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps, and how many distinct ways can you climb to the top? Alright, so just before even getting into the examples, let's imagine a staircase. There's the floor, and then each step is represented here as 1 step in n. So a 3-step staircase would be the floor, and then 3 more steps. Each time you can either climb from 1 or 2 steps, and how many distinct ways can you climb to the top? So this, although it's an easy problem, this seems like a dynamic programming solution, and the question that poses the question that makes it a DP problem is, given that we are starting from some number of variations to get to the current step, how many variations are there to get to the next however many stairs? So if we are starting from one type of way to get from to the current position, then the next step would be, for example, 1, because we can get there by stepping right to that step, and 2 steps away from that would be 2, because we can get there. The first variation of getting there would just be to step over 2 stairs at the same time, or step from the previous step where we have already been. So you can kind of see the dynamic programming coming in. You are currently holding some information, which is the number of ways to get to the current position, and then you're pre-populating some element of the solution forward. So the example here is we have 2 steps and there are 2 different ways to get there. And then a quick explanation. Same goes for this, right? So in the 2-step variation we already discussed, but the 3. There's 3 ways to get there. Let's see. There's 1, 1, 1, 2, 1, and 1, 2. Yep, that all aligns. Let's start. Unique paths is going to be 0. That's going to be the value that I'm returning. I'll have my DP array that starts with 0, and let's have the size of it be n plus 1. That's going to include the first floor, or the ground floor, and let's set dp of 0 to 1, indicating that initially there's one way that we can appear on the ground floor. And then simply for for step in range len dp, I would say that the current paths is just equal to dp of the current step, and then all I need to do is look forward either once or twice and decide whether I'm able to or no, not decide whether I'm able to, but complete the number of ways that I need to, or pre-fill the those future steps with their number of unique paths. So in this case, if step plus 1 is less than length of dp, the reason I'm doing this again is because there is a chance that I'm already looking at the last couple of steps and there's no need for me to pre-fill this. Then dp of step plus 1 is going to be equal to the addition of current paths. And then very similar thing is going to be with the 2 steps, right? And I believe that's it. We can return unique paths here and run. And let's have that be -1. If forgot. The last element of unique paths is going to be the thing that tells us how many different paths to get to the top. Let's run. Oh, wait, I don't even need this. I just need dp of -1. There we go. Submit. Got carried away with the naming. We're beating 81%, not bad, but since it's not below 90, let's look at some of the better solutions. Previous prev2, prev2. I see what they're doing. So instead of having the DP array, they're saying they're keeping in mind, this is very similar to, I guess, the Fibonacci sequence approach, where you just are aware of the previous and the prev. Okay, so then for I in range 2 and n+1. Okay, let's try this. I like that approach. We have the prev that represents the previous step, and prev that represents the so this is the previous step 2 steps ago, and then just the previous. And then for I in range 2 to n+1 because we are starting from the ground floor and we're avoiding hitting those first initial 2. We're saying that prev and prev are equal to, prev is just equal to prev and prev plus prev. And let's return prev. Right? Yep, that does seem to work, and probably works faster. So, does not work faster. Alright, well, if it doesn't, then there's always this approach, which puts it at 81st percentile. I like both of these. I like this one a bit more because it's more elegant. There's no need for a DP array. However, the use of the DP array is very standard in dynamic programming problems, so that one is also valid. Okay, well with that, let's end today's video. Thanks for watching. Please like and subscribe, and I will see you tomorrow. Bye.